Alright, welcome everyone. We're going to get right to it here. I'm going to take you through the Unit 2A final exam review. Alright, so we're going to move quickly here today. First one here, so what we're doing is we're looking at a scenario and we are trying to break it down into the starting bit, the rate of change or the slope, and then the output value. So we have a pizza that costs 18 bucks for 3 toppings, so I'm going to go ahead and put a box around what I think is important here. I will tell you that this isn't my favorite problem in the world because this 3 toppings, this number is kind of has the potential to throw you off a little bit. So I'm going to get rid of that here. So pizza costs 18 bucks. That's going to be our starting amount here, plus another $1.50 for each additional topping. Okay, so that's what kind of tips you off that this is the rate or the slope here. It's $1.50 for each additional for each additional topping. All right, then your pizza cost is a total of $25.50. So we're gonna have kind of a similar format for all these here. I'm gonna go ahead and put this over on the right side of my screen. So we have the starting amount for each of these, and then we have the slope or rate of change. And that's going to be multiplied by some variable we'll call x. All right, and that is going to be equal to some total. Okay, so linear equations here. We got a starting value. We're adding some rate times a variable equal to our total. Okay, so we got pizza cost 18 bucks. So I'm going to start out with that 18 bucks plus another $1.50. So 1.50 or 1.5 if you like, for each additional topping. So if we go ahead and call let's use t as our variable here. You can use x, you can use whatever you like, but I'll go ahead and use t for topping. Is going to be equal to our total of $25.50. All right, then here it just wants to define our variable, and that's going to be t, the number, this is just the symbol that represents number of additional toppings. Okay, so just the number of additional or added toppings. All right, let's take a look at our next situation here. We have an online gaming membership that starts with 5,000 minutes. So once again, we're going to follow our formula for success here. So starting amount here is going to be 5,000 minutes. And you use or take away 15 minutes for each credit played. Again, for each or for every, that's kind of tipping us off that this is going to be the rate. So 15 minutes for each credit played, that's the amount that we are losing. So since we are losing or taking that amount away, we are going to be subtracting that. So let me try this again here. Minus 15 minutes for each credit played. I'll go ahead and use C here to represent credits. And that's going to be equal to our total. So your membership now has a total of 4,370 minutes. All right, so starting amount of minutes 5,000 plus our rate times some variable, so plus negative 15 because we're losing or taking away 15 minutes for each credit, and then that's going to be equal to our total. Once again, defining our variable here, we have C is equal to the number of credits played, or just the number of credits, we'll say. All right, moving down here, you decide to have a late Halloween party and need to go shopping for snacks and sodas for your party. You spend 50 bucks on snacks, so that's going to be our starting amount here. So we start by spending 50 bucks and an additional 5 bucks on soda for each. There's our clue that we're talking about a rate here for each person who attends. So we're going to add an additional 5 bucks for each soda, and I'll go ahead, an additional 5 bucks on soda for each person. Okay, so we're going to use P for person. All right, so our variables here, P, that's going to be the number of people. All right, so 5 bucks for each additional person who attends. And then here we're going to have to use a second variable here because they didn't actually give us the total. Remember, we're looking for starting amount plus some rate times the variable equals our total. In each of these first two, they just gave our total to us. So our total cost here was $25.50. Our total amount of minutes was 4,370. Here they have not given us that total. So we're going to go ahead and just use a variable. And we are modeling the cost here, right? We start with $50 plus another $5 for each person. So I'm going to go ahead and use C for cost because that's what we're actually trying to find here. So C is the cost, or the total cost. All right, last one here. The cost of concert tickets is $95 for each ticket, plus an extra $5 for each soda you buy, and $40 for parking. This is a tricky one. We have a bunch of variables here. All right, we're going to write this equation out. Here it's going to be a little bit trickier to determine which is our starting one, so we're going to do this carefully. We have $95 for each ticket, so that for each, again, tells me that we're probably talking about a rate, plus an extra $5 for each soda you buy. Okay, so once again, I see that for each, so that $5 is going to be giving me some sort of rate, and $40 for parking. Okay, so I notice that in this term here, in this quantity, I do not see a for each or a for every. So I just see $40 for parking, just a flat fee for parking. All right, so we're still going to follow our same formula here. We have our starting amount plus our rates equaling our total. This time we just have two rates instead of just one. All right, so let's go ahead and get rolling here. Our starting amount is just going to be this $40 for parking. Right, so we start at $40. Before we start adding on our rates, just to get there and park, we have to spend $40. All right, then we're going to add on to this $40. We got $95 per each ticket, and I'm going to define my variables as I go here. So $95 per each ticket. I'll use T as my variable for ticket. Okay, and I'll put this over here as well. T is number of tickets. All right, and then an extra $5 for each soda. So we're going to add another rate on here. So it's going to be $5 for each soda. I'll go ahead and use an S for soda. All right, calling out my variables over here. S is sodas. And then variable 3, so once again, they have not given us a total. Right, so we have to have start plus all of our rates equaling some total. We have not been told how much this is all going to cost. So once again, we'll use C to represent cost. All right. So $40 to park plus $95 for each ticket plus another $5 for each soda will give us our total cost. All right. Moving on to the next section here, we are just plugging and chugging, just evaluating some equations when given a value. So here we have 1.99x plus 17 equals y, and they say, what if x equals 11? Go ahead and evaluate. So all that means is they want you to rewrite this equation here, 1.99, but instead of writing x, we're going to substitute this 11 in for x. Right? So they say, now we know that x is equal to 11. Instead of writing this x to represent a mystery that we don't know, we do know that this thing is going to be 11. All right, so as always, whenever there's a number squished right up against a letter, there's an invisible multiplication sign in between there. All right, just writing this whole thing out here. Right, 1.99 times 11 plus 17 equals y. We are going to kind of cruise through this here, since you can do this on your Desmos calculator if you were to do this on a test. However, you do still need to know the order of operations here. So we got multiplication and addition. Multiplication is going to come first. 1.99 times 11 should give you 38.89. All right, 38.89 plus 17 equals y. The trick here is not to do too much at one step, just doing one thing at a time. Adding these two together now, you should arrive at, 1.99 times 11, and then plus 17. All of that is going to come out to 38.89. All right, so final answer here is just 38.89. All right, Next one here, if x equals -4, this is a new equation that they want us to plug in for. So we got 2 in parentheses, -4 plus 15 minus 6 equals y. Again, just plug in that -4 in for our x. And we're going to go ahead and start in our parentheses here. So we have -4 plus 15. So going back to PEMDAS here, parentheses come first before anything else. -4 plus 15, that's going to be positive 11. So there's 11 more positives than there are negatives here. All right, just doing one thing at a time here. All right, so now we got 2 times 11 minus 6. Your calculator should be able to handle this for you, and it will come out to 16 equal to y. So y equals 16. All right, page number 2, halfway done here. Back to some situations. So we got a car wash that has raised $236, and we'll add $12 for each car they wash. So $12 for each. Again, that tells you that you're talking about a rate or a slope, and the goal is $500. So this is going to be our total. All right, they want us to solve this equation and explain the meaning of the solution. So let's take a look here. We have our starting amount of $236 plus an additional, this is going to be our rate, $12 per something, equal to our total. So they want to know what that something is here. And if we look carefully, it's $12 for each car that they wash. Okay, so this is going to be cars that they wash. So at the end here, we're going to have x equal to something, and we need to make sure to explain that that is the number of cars washed. Okay, so be really careful on this final exam. Make sure that you are answering every single question that is asked of you. All right, so we're going to solve this thing here. What I like to do is go ahead and just draw a line down the middle of my equation, because we want to make sure whenever we do something to one side of this equal sign, we have to do the same thing to the other side. All right, so let's go ahead and get rolling here. We're trying to knock off everything on this left side except for the x itself. And the way to do that is start on the outside. So start as far away from the x as you can. We have a 236 sitting over here on the left side. There's an invisible plus sign here, right? If you're not given a positive or a negative, it's just plus. And the way to get rid of positive 236 is to do the exact opposite, and that means to subtract 236. All right, since we're doing that to the left side, we have to do the exact same thing to the right side. So we're going to go ahead and subtract 236 on the right here. And that's going to bring us to, so 236 minus 236, that's going to cancel out. See you later. I'm going to bring down this 12x. We have not done anything to my 12x. I'm putting a box around the x just to remind myself that that is my goal, is to get that box all by itself. And then 500 minus 236, again, you can do this on your Desmos calculator. That's going to give us 264. All right, so right now we have x almost all by itself. It's still got one buddy though. It's hanging out with this 12, and it is being multiplied by 12, right? There's no operation in between our number and our letter. That means there's an invisible multiplication sign there. All right, so opposite of multiplying x by 12 is going to be dividing by 12. That's going to get rid of that thing. If we do it to the left side, we have to do it to the right side as well. All right, so divide the right side by 12 as well. We get our final answer, which is x equal to 22. X equals 22. All right, moving on down to number 4 here. Getting close to the finish line. The graph to the right represents your savings account over time. Use the graph to answer the questions below. All right, first one, how much money did you initially deposit in your savings account? So it's just as up above here, we're looking really at two things. Let's see if this will actually let me switch over. Guess not. Huh. Okay, so how much money did you initially deposit into your savings account? We're going right back to the same old formula here. We have starting amount plus some rate times a variable equal to our total. Okay, so same deal here. The only difference is we're going to start calling these by some different names. So when we're talking about the starting value for a function, when we're looking at a graph, what we usually refer to that as is the y-intercept or the vertical intercept. Right? And the reason why we call the starting value the y-intercept when we're looking at a graph is that thing is the point that touches the y-axis. Okay, so here we have an amount of money being earned, so we're modeling the amount of money that's being earned over time. At 0 weeks, so right here at 0 weeks, we're starting with $30. Okay, so that's why we call it the y-intercept. It is the starting value. It is also where we hit the y-axis. All right, so how much money did you initially deposit into your account? We deposited 30 bucks. All right. Next thing here is going to be the rate. So we need to talk about rate as well. When we are talking about rate and we're looking at a graph, usually we like to call that the slope. Right? And the reason why we call the rate the slope when we're looking at a graph is the way we see the rate is we look how much we're going up and how much we're going right. How far are we going up and how far are we going right? Okay. The next one says after 5 weeks, how much money is in the account? So we don't have to really use rate much yet. All we need to do is know how to use our axes. So after 5 weeks, I'm looking at my graph here and I see 5 right there. How much money is in the account? All we have to do is follow this grid line up. And then if we take a look to the left here, so we're halfway between $50 and $60, that should be $55. $55. All right, how long will it take you to have $70 in the account? So this time we're doing a very similar thing. Again, the only difference here, the only difference here is instead of being given an input, so now we know about functions, we know that our horizontal axis here is our input axis. Now we're actually given an output. So we're given an amount of money, which is on our output axis here, or our vertical or y-axis, 70 bucks. Okay, so 70 bucks in the account. That happens at, let's go over here, and we'll follow this thing down, 8 weeks. So it takes 8 weeks to get 70 bucks in that account. All right. Next one here, you recently started playing video games competitively and needed a new laptop. All right, so we have a laptop loan here. We have the amount that is owed on our vertical axis here, or our output axis. And then the number of weeks that has gone by is going to be on our x-axis or our input axis. All right, so how much did you pay your parents for the computer? So I'm going to put the success formula here up again. So we got start plus rate times some variable equals total. Okay, so what they've asked for here is how much did your parents pay for the computer? We are actually looking for the starting amount. Okay, so we got the amount that is paid for the computer, and then as we're going down the line here, we are slowly paying this thing off. Okay, so the starting amount here, or the y-intercept, is going to be $1,000. So your parents paid $1,000 for this computer. All right, how long will it take for you to pay your parents back? So here we're taking a look at our number of weeks here. So this is week 0. This is where we begin. As the weeks progress, we are owing less and less money, so we're slowly paying this thing off. And then right here, this is our x-intercept, where this hits the x-axis. And this took 10 weeks. So it's kind of hard to see there, but that's a 10 there. So it took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 weeks to pay this thing off. All right, next one is true or false. After 6 weeks, you will owe your parents $600. So we're just going to go ahead and check out our coordinate grid here. So after 6 weeks, we'll find 6 weeks on our input axis here. You will owe your parents 600 bucks. So let's go ahead and follow this thing up and see. Going over, that is not true. So after 6 weeks, you'll owe your parents $400. That is false. Last one for today, find the slope of the line and explain what it means in context. So this is finally, we are getting to our rate or our slope. All right, and the trick here is we are going to find the change in y, so the change in the vertical variable, and divide by the change in x. Okay, so on top again, change in y, that's going to be either how much it goes up, which would be positive, or how much your function goes down, that would be negative. On the bottom, the change in x, you're always going left to right, so you don't need to worry about positives or negatives there. So you only worry about positives and negatives up top. You always read graphs going from left to right. Okay. So slope of the line here, all we need is 2 points. So let's go ahead and use our starting point here. So 0 weeks, we have $1,000 left on this loan. All right, so I got my x-axis here, I got my y-axis here. When I'm giving a coordinate, I give the x-coordinate first, and then I give the y-coordinate. Okay, so x-coordinate 0, y-coordinate 1,000. All right, so that's just a point that I chose to use. You can use any point on this line. The next point I'm going to use here, let's go ahead and use this one right here. All right, so my x value for this point is 4, right? So if I follow this point down, I see that my x-coordinate there is 4. All right, again, just sticking our x value first and then our y value. And then the y value, or the output value at this point here, is 600. All right, so again, we're going to do the change in y divided by the change in x. So going from left to right, this thing is going down 100, 200, 300, $400. So change in y on top, this is going to be negative 400, right? Because if we go up, it's positive. If we go down, it's negative. All right, and then the change in x here, so I'm going to go to the right here. I'm going over 1 week, 2 weeks, 3 weeks, and 4 weeks. So on the bottom, we have 4. All right, negative 400 divided by 4, you can do that on your Desmos calculator if you don't know. That is negative 100. And what that means, we need to get some units on this thing. We are going down $100 every week. So your parents are paying off $100 every week, or for each week. Okay, so that is how fast they are paying this thing off. That is the rate at which they are paying off what is owed on the laptop. All right, thanks so much for watching, everybody, and I will see you in class soon.